Hi, wonderful students. Let's look at this question on heat capacity we just discussed. Aluminium metal at temperature 10 degrees Celsius is heated through, so it means here not cooling, heated, to 28 degrees Celsius. If the heat capacity of aluminium is 670.0 joule per Kelvin, calculate the amount of heat energy. Wow, this is a very simple question. So you put down the information that you have been given. So the 10 degrees Celsius is what? The initial temperature. Okay. So we are given initial temperature is equal to 10 degrees Celsius. We are given the final temperature as 28 degrees Celsius. Okay. Initial temperature of aluminium, Al. All right, that is a symbol. Now, we are given the heat capacity of aluminium. Heat capacity of aluminium as 670.0 joule per Kelvin. Okay. So we are looking for what does the question demand? We are looking for the amount of heat. We are looking for the amount of heat, which is the same as the quantity of heat, right? Yes. All right. We are given the heat capacity of aluminium, which is a capital C. So the question is, how do we find heat capacity of aluminium? If you want to find the heat capacity of aluminium, how do you find it? Heat capacity of aluminium is going to be what? Amount, or because I have defined my term already, it's going to be Q over what? Change in temperature. That's all. Are we following? So look at the question carefully. Let me call it theta. Change in temperature. I have denoted it by theta. So now how do I find theta? Theta is going to be my final temperature minus what? Your theta is change. And we have said that temperature change is the bigger value minus the smaller value, okay? So what do I get? 28 minus 10. And I'll get what? 18 degrees Celsius. Don't forget this. Temperature change in degrees Celsius and temperature change in Kelvin are the same. Still temperature change. So there is no need converting this. One thing you should know is that there is no need converting this one to Kelvin, okay? There is no need. Temperature change in degrees Celsius and Kelvin is the same. It's the same temperature change. So though the heat capacity is given in Kelvin, you don't have to change the temperature change to Kelvin. No. Don't worry with that. Now, let's move on. So the question wants us to find Q. So let's substitute our values. It becomes simple. So we continue from here. So we are giving the 670 equals what? The heat capacity is the 670. And we are asked to find the Q. We found our change. We found our change in temperature to be what? 18. Okay. 18. So what do? We are just doing simple change of subject, making K the subject. And we are good to go. So what do we end up getting here? We are going to get K to be what? 670 times 18. What do we get? 670 by 18 will give me 12,060. And because it's heat energy, the SI unit is recorded in Joule. So that's all. Let's conclude. We will simply say that the amount of heat is the amount of heat required is 12,060 joules. So that is all. Very simple question. This was the question. This is how we took down our information. Let me capitalize this one. And we ended here. Great. So on that note, let me give you this. Try this one and let's see what you will get. When I tried it, this is the answer I had. Solve and see if you will land at the same answer. And let me hear you in the comment section. Thank you and see you in subsequent.